Welcome to lesson unit 7-11. This is our final lesson in unit 7. It's been a long one, I know, but we got through. This is our rate problems. So we'll be talking about that. Kind of the speed of things, how two rates compare, and so on. You'll see. Math career for today is a biostatistician. Biostatisticians design research studies and analyze data related to human health, animals, or plants. The healthcare, biomedical, and pharmaceutical fields employ biostatisticians who are responsible for analyzing genetic data, disease occurrence, and medical imaging data. All right. So, really important job for high population centers especially. You see your math you needed there. Nice, healthy salary. A lot of medical here. A lot of chemistry. Lots of math. Lots of good times. If that's your strong point, that's something you're interested in doing. Good career. Biostatistician. All right, today we will learn to solve rate problems. So, do we recall D equals RT? Distance equals rate times time. For example, if we travel at a rate of 50 miles an hour for 2 hours, what's our distance? Well, 50 miles an hour times 2, distance 100 miles. Okay. All right, now we have learned how to work with mixture problems. We focused on percent. We know how to handle work problems. We combined two things, find a common denominator. So now we need to learn about rate problems. So sit back and watch this one. You might want to add this one to your notebook. I know I have the icon up there that says to watch, but you might want to add this one. We're going to have one example for you and one for you to practice on your own, and then we'll work together in class. This can be a little messy here, so hang in there, stick with me, and if you want to jot some stuff down, I'd recommend it. A passenger train travels 20 miles an hour faster than a freight train, and it takes the passenger train 2 hours less time to travel the 240 miles. How long does it take the freight train to make the trip? So you've got two trains now. Just have them in your mind. You've got a passenger train, and it's going to travel 20 miles an hour faster. So for every hour, it's traveling an extra 20 miles. And it takes it a total of 2 hours less time to travel a particular distance. Okay, so if you've got two trains traveling side by side, the freight train is slower. So recall, distance equals rate times time. So let's look for key information. 2 hours less time for the passenger train, a total distance of 240 miles an hour, 240 miles, and the passenger train travels 20 miles an hour faster. So here's a little helpful thing. Always start with the slow train or the slow car, or the slow boat, whatever. The slower one, the slower runner. So the distance here is 240 miles. We don't know the rate. We don't know the time just yet. Okay, so that's what we're working on. So 240, that's distance, equals the freight train's rate times its time. Now, if that's the case, then we could certainly be able to isolate for the rate, I believe, by dividing by t, correct? So if d equals RT, divide by t, and we solve for r. So the rate of the freight train, whatever it is 240 over t. Now for the faster one, we know that the time it takes the freight train, the passenger train is 2 hours faster. So if you notice what I've got here on this side over here is that the 240 miles times equals the rate times the time. But the time here compared to the freight train, wouldn't it be 2 hours faster? So now let's do the same thing. Let's go ahead and solve or isolate the r for the rate. And we end up with this rate is 240 over t minus 2. So establish the first one is the slow guy, set it up. The next one, we know that this passenger train takes 2 hours less, so whatever the time is, subtract 2 off it. Okay? All right, let's go to work now. We're going to set the rates equal to each other. In order to take the next step here. So 240 over t plus 20 equals 240 over t minus 2. Well, where do you say the plus 20 comes from? In order to set them equal to each other, wouldn't we have to increase the freight train's speed by 20 miles an hour? So we'd have to add 20 miles an hour, maybe a dangerous thing. Those freight trains are pretty big. We'd speed that train up 20 miles an hour to set it equal to the passenger train. Now they're running side by side at the same rate. Okay, multiply both sides by the least common denominator here. And this is, of course, where things get a little messy. We've got a t as a denominator. We have a 1 as a denominator. and we have a t minus 2 as a denominator. So hold on to your hats. Here's what it looks like. All right. T times t minus 2 multiplied by 240 over t plus 20. So our least common denominator here is t times t minus 2. So we're going to multiply both sides by t times t minus 2. So just be careful. Start eliminating things. Don't be in a hurry here. Okay, we're not on a bullet train. Just take your time. It looks like the t's are going to cancel here. Okay, so if I were to grab my trusty pencil here, and let's see, it looks like the t is going to cancel here and here. And this one, wouldn't the t minus 2 cancel here? So then we can multiply these two together, and we can multiply this. Now this will be a little bit messier here, but we can do it. Okay? All right, let me get rid of that if I can. It takes me a second here. There we go. Okay, let's see what happens next. So we're going to end up cleaning this piece up, and we end up with that on the left-hand side. Now we have to clean that up. Just reorganize it, combine like terms, and if you're careful, what you'll see is it turns out to be this. There's a lot of micro steps in there, stuff you've already studied, we've already done. I don't want to fill up 2 screens doing it. Just combine like terms, pull the 240t over, subtract it, and all that. Now notice what you've got there. 20t squared minus 40t minus 480 equals 0. Let's factor out a common denominator. So I'm going to wipe out a whole bunch of stuff there and streamline this all the way down to that. Much nicer. Now we can kind of take a deep breath and relax. That's a nice, easy x problem. I need 2 numbers that multiply to negative 24 and add to negative 2. How about t minus 6 and t plus 4 equals 0? That gives us 2 possible answers. What would make this here in our first factor true? Would that be a 6? So t could equal 6, or t could equal negative 4. Well, now think about what we're talking about here. Can time be anything lower than 0? The answer to that is no, of course. So it looks like negative 4 is an extraneous solution, correct? Negative 4 is out. The only answer left is 6. So it takes 6 hours. How long does it take the freight train to make the trip? 6 hours. By extension, how long does it take the passenger train to make the trip? Well, 4 hours, right? Because it's 2 hours faster. All right. I know that's a little bit messy there, but we can do it. We can do it. All right. This one here, I want you to practice this one on your own. I think we can finish this in class together, but go ahead and give it the old college try here. Amber runs along a 16-mile trail while David walks. Amber runs 4 miles an hour faster than David walks. It takes David 2 hours longer than Amber to cover the 16 miles. How long does it take Amber to complete the trip? All right, so remember, start with the slow one. Well, obviously the slow one's going to be Dave here. Establish him, and then set your rates equal to each other and solve. All right, so try this one on your own and see how you do. And that's it for Unit 7-11. In fact, that's it for Unit 7. That's a long journey there, but we got through it. If you'd like more instruction, navigate there and watch that video example 3. And there's some digital and scored practice there at the bottom. All right then. Enjoy, and we'll talk to you soon.